Welcome to X281 Lab 1. My name is Oliver Hill. I'm GSI this semester. And since I think it's weird to not be able to see who's presenting, this is me. I'm a master's in data science at U of M, but I was CSC undergrad and I've taught X281 this is my fifth semester teaching X281. I originally took it in the spring semester, so I'm really excited to teach in the spring semester and help you all. Um, should be a good time, and hopefully we'll be able to deal with the online classes and it won't be too hampering to your learning. In the interest of that, please let me know if there's anything that you would like to see further from the topics of this video, or whatever, over Piazza, over email. You can find my unique name probably on email, I guess, or on Piazza, whatever. But, so let's get into it. Today we're going to be talking about make files. We're going to go over a bunch of like logistical stuff with Kane. I'm going to help you like log into Kane and make sure we all have Kane accounts, and we'll be discussing some tools that you can use on Kane that will help you do projects and labs. And then we'll be talking a little bit more about like C++ specific stuff, things that will help you in your projects in the future, and a little bit about vectors right at the end. Okay, let's get started. Quick announcements. Lab 1 is out today, and today is currently Monday, but I think it'll be Wednesday when this is released. And it's due the following Friday. So this will be the structure for almost all the labs in the spring semester of X281. You'll have a lab or two per week, and any lab will be due the Friday of the week after it is assigned. So this one will be due Friday, May 15th. Yeah, it's good to do labs early. They're usually not a lot of work. There's a couple later in the semester that will require a bit more time, but good to just get them out of the way. Project 1 will be released, as I'm speaking now, on the 4th, but it'll be released on the 5th, and it will be due on the 12th. So very quick turnaround on Project 1. There's not a whole lot of like new concepts per se. The thing that you'll likely be struggling with is having to optimize things you already know. So you'll be using things like vectors or stacks or queues, but now you'll have to think about what's the best way to do something, what's the fastest way to do something. And that's sort of the mantra of X281. So it's a good way to start us off. I find that usually in X281, optimization is hard at the beginning, and then concepts are harder at the end. So if you're struggling with like timing or memory issues, don't worry about it. Everyone does. I certainly did. Okay, so this is what we'll be talking about. Intro. There is, lab attendance in quotation marks. There will be handwritten code that you'll turn in on Gradescope, I believe. We'll go through and grade them for every lab. But it is a significant portion of every lab, and it's just, they're just like small programming problems. We're not really looking for like, we're not going to be very vindictive about the grading here. Well, hopefully, hopefully we aren't ever. But it's more of like, did you do it? Did you try? If you just have a C out statement that's like, I don't know how to do it, then we're not going to give you the points. But so just try your hardest on the handwritten problems, and we'll go from there. Okay, if you have any individual questions, feel free to email us. You can also post private posts on Piazza. We'll, you know, we'll try to help as much as we can. It's definitely a hard class, and we're here for you. Here's your grade breakdown. Projects are 40% of your grade. The exams are 40% of your grade, and the lab assignments make up the remaining 20%. Here are the dates for the midterm and final, and minimum competency. I'm not going to go over those, but that is information that you should know. Projects, exams, and labs are all under the engineering honor code. So you should know how this works from 280 and 183 or 101 if you took that at Michigan. Exams, you know how it works. You know, we all trust each other. Labs, you can work with partners, but both of you have to submit the code. So if you work with a partner, it's not enough for one of you to submit to the autograder and get 100%. You're both going to have to submit. We don't like register you in our system or anything, so it's just you both have to submit. There will be a teammates post on Piazza when we get that going that you can find lab partners if you want. You certainly don't have to have lab partners. Up to you. You can submit totally identical code with your partner for the lab. Okay, some success tips. Obviously, this is like the often repeated statement of EECS at Michigan, but start your projects early. This post in particular, I believe, was like the night before Project 2 was due a couple years ago. And of course, the person is not happy about what they've been doing. So please start early. We've got more time in office hours. We've got a lot more resources to help you usually in the earlier part of a project. In the later part, there's usually a bit more demand on those resources. And particularly in spring, you know, I mean, you're taking the class, so you should know this, but spring 281 is tough. The projects are on a short timeline, so we'll be working hard, and we want you to succeed. So start early. Come to office hours. Searching, like Google, Bing searching, whatever, is going to be your best friend for this class and also for the future. Just learning, you know, how to efficiently search for things on the internet will help you greatly. If you see errors in your code, just throw it into a search machine, and I'll bet something will come up that'll help you. We highly recommend thinking about your plan before you begin implementation, but sometimes, you know, a lot of what I'll do is like write a bunch of code, and then I will realize that I was trying to solve a problem different than what the project was asking me to solve, so I have to tear it all down, and then I can rewrite my code, but it'll be a lot better because I actually understand what's going on. So that's definitely a perfectly viable way to go. Please talk to us in office hours. We're happy to talk about program design and structuring and all of this. We're definitely there for that, so just let us know. All right, so Lab 1, we're trying to get comfortable with some of the tools you'll be using for the rest of the semester. There's also a great optimization tips document in the resources folder on Canvas, and the STLNU document in the Project 1 folder. Those are both really good places to look when you're feeling a little stuck about memory or time optimization. They have a lot of tips about places you can look and different strategies you can try. So I definitely recommend going over those and also rereading them throughout the semester. And then reading the specs in their entirety multiple times throughout the project. So what my thought process at least is usually I'll read the spec through one time right when it gets released. I'll be really scared and freaked out, and I'll code something up and it usually won't work or it'll be really slow or whatever, and then I'll go back and read the spec all the way through again, and then I'll start like really honing in on what exactly the problem is and where the issues are in my project. So I think reading the spec throughout the project is really helpful. You'll always pick up like little things that you miss that'll help you pass the test case here and there. So good to do. Okay, for debugging, we definitely want, one of the goals of this course is for you to get good at debugging on your own. We don't want to be a crutch for you. We want to be able to support you more longitudinally. So we want you to learn how to write good test cases, learn how to walk through your algorithm. I tend to use a lot of print statements, but definitely like using an IDE and being able to step through, like Xcode or Visual Studio or something, and being able to step through your code and see what variables are being assigned to, and et cetera, et cetera. Very helpful. Rereading the specs, submitting test cases to the autograder. We give you points for that, so you should definitely be doing it. And then Piazza is usually very helpful. A lot of the people run into the same problems because there are specific hard parts of all of the projects, so definitely worth always checking on Piazza. Okay, in terms of IDEs, here's an example of what we could, what IDEs can help you do. You have an area where you can look at your variables and you can look at the values of those variables as the program runs. You can look at the types. Very convenient and nice for a lot of the projects. It really helps you nail down bugs very quickly. But also they give you these error lists that are nicely parsed from the sometimes you'll run your code in the terminal and it'll just be like this disgusting 1,000-line output. So the IDE will parse that and show you exactly where the problems are and what they are. So here we're seeing we're missing a semicolon on line 762. Yeah, so it just makes things a bit easier for you. You certainly don't have to use one, but it's nice. Dr. P will probably, not look at your code or whatever if you're not using an IDE. Just kidding. He'll of course look at your code. Okay, great. So project grading. After submissions are closed, there's the final submission date on AutoGrader. After that date, we're gonna take whatever your best submission was. So whatever the like highest graded submission, and we'll run that again on its own on the AutoGrader. So everyone has their best submission run completely separately on the AutoGrader. So this hopefully is like leveling the playing field as much as possible, and giving you the best opportunity to run as quickly and as efficiently as possible. Because a lot of times CPUs will get bogged down when they have multiple threads and processes going at the same time. So there will also be hidden test cases that will be run at that time. This isn't X280. We're not throwing in like the majority of the testing code to the hidden test cases, but there are. It's more just like general testing. Like we're not really trying to trick you at that point. Yeah. If 2 or more submissions are being tied, we take the most recent. You can talk to us about that if you want. All right. Okay, in terms of Kane, your code has to compile and run with the version of G++ that's on the Kane machines. This should be the same as 280, I believe, so keep doing that. If you're developing on your own computer, which I think most people do, you need to find a way to compile and test your code on the Kane machines as well. This could be something like, you basically have to get all your files over there. So you could be using FileZilla. You could use SSH and SFTP or like command line options. You could use Git. Git is really nice because it's also version controlling your stuff at the same time, but if it's a pain, you do you. Okay, so now we're going to get into a little bit of the Kane stuff. So I'm going to log into my Kane. That's probably a little too small. Let's do that. Okay. Hopefully you all can see that. Okay, so type something like this into your terminal. Mine may be a little fancy, but ignore that. Okay, so that is not ideal. Ooh, network is down. Oh, it's my network. Sorry, y'all. Just gonna reconnect here. Okay, there we go. All right, push. And hopefully, if my computer is still connected to the internet. All right, there we go. So I'm in my Kane terminal. Something very important in this class is to run the correct G++ compiler. We have to type this command at the terminal. Come on. Okay. So that loads the proper version of GCC into our workspace. If you want to ensure that it just always runs and you don't have to think about it, you can go into your bash RC. Oh my gosh, it's taking so long now, I'm sorry. I'll try to quit some things. Okay. All right, bash RC, and you see right at the top, I have module load GCC 6.2.0. That will allow you to, well, it allows you to not type it in. So this file runs every time you log into Kane. So you won't have to type it. You just go into bash RC, you type that out, and then quit. So those instructions are right here. You can do it in your bash profile, you do it in your bash RC, it doesn't matter. They both run right at the beginning. Okay, great. So one thing that I want to show you is it's just a little trick you can use. It's not really a trick. So you can either type this out every time if you want, or what I like to do is I can do this, and then I'm automatically on. So what you do for that, if you want to, so we're going to go vim. All right, so you want to make sure that you have this .ssh folder and your home directory. So we're going to go in there. And then you have a bunch of stuff here. You're either going to create a config document or there will already be one. But then in here, you will put just a few lines of code. So all you need to do is put this in. This is the only 3 lines you need. I just do host Kane. Host name will be the same for you, and then user will obviously be different. So mine is Oliver High. If you're interested in persisting an SSH session over multiple windows, so for example, You know, if I open up a new terminal, I don't have to log in again, and I won't have to for 10 minutes, as long as I'm logged in. And then if I log out with all of them, after 10 minutes, I'll have to relog in. You can put this into your SSH config file. Up to you. Okay. So, moving on. Don't use mfile. Mfile will corrupt some of your files potentially. You can, you know, make GitHub and GitLab repos for free. You can use SFTP. You can use rsync. These sort of things. You can use FileZilla. Is a good option, I would say, for like a GUI-based file transfer. But yeah, just have some way to get it over there. All right, make files. So let's see. We need to compile G++. G++ is kind of a pain, especially if you have, you know, these projects with like 5 or 6 files, or if you go, you know, work at some large company, then you'll be compiling like thousands of files together, and it's horrible. So what we want to do is automate that process essentially. We can compile all of our source files into a single executable. We don't want to type this out every time. So, especially if we're doing this is really bad because now we're compiling main.cpp into an executable called main.cpp. So now we've overridden all our code. Not a great situation. Same thing here. So makefile is basically just a file that automates this process for you. So if we go into Kane, and my stuff is in here, 281TA / lab1 test. Okay, great. So, and actually something I wanted to do was show you the whole process of, you know, getting your lab files and all of this. So, likely what you will see when you download the lab files from Canvas, say you'll have this tar.xv file, tar.gz file, sorry. So I'm going to SFTP, and I'm going to go into my 281 folder, and I've got a file that I'm just moving over through SFTP, lab1.tar.gz. Okay, so now if I go up here, we'll see that I have lab1.tar.gz, and I'm going to close that. And the command is, let's see, the command is tar dash, I think it's xvzf, and then lab1.tar.gz. Okay, so now I took lab1.tar.gz. It created a folder called lab1. You can see it wasn't here. Now it's here. I'm going to go into there. It's got you know, the 3 files that are supposed to be in there all set up. So now what I can do is I've already got my makefile in here. Let's go take a look. It's a whole bunch of stuff that you don't have to worry about, but there are these 3 to-dos that you do have to worry about. The executable is what you want dot slash whatever. It's this thing. It's what you'll actually be running. Your project file, I would, it's like main.cpp or project1.cpp or whatever you want to call it. This, I will say, is usually specified in the spec. So it's something you want to keep track of and something that we'll be telling you because we need it to be named a certain thing for it to run on our autograder. Project file is, again, like main or project1.cpp. And then the last one is dependencies. So, if I was doing like, if the executable was project1, then maybe it would rely on project1.cpp, and it would rely on treasure.cpp, and also like treasure.h, and maybe map.h. Okay, something like that. And then they would all get compiled into the one executable. So this is where you're taking all of your, you want to be running the project file, but you also want these other files included in that. But usually what you can do is just look up, to do within the file, and you'll find all the places that you need. Okay, just quit out of there. All right, so that's what this is saying. Executable name, that's something we give you. All right, project file. I just use this, honestly. I'll just name, whatever my name is, just put it there. Okay. There we go. And then, yeah, so just, go find the to-dos and it'll tell you what to do. All right, so a little bit about dependencies. Our target name, in this case, we're compiling main.h and main.cpp into a object file. So we're saying the end result relies on these two objects. And then we'll have this is the command to create that object. Okay, so there's a few different things you can do with our makefile. You can do make, or make all is equivalent. You can do, so now we have a couple extra files. We have profiling executable, profiling.o. We can do make clean, which removes everything we just created. We can do make debug, which compiles a special version of the executable called profiling debug that gives us a little more information when we try to debug with it. And we can also do make profile. This is the executable here, always at the very end of the compilation process. And that gives us just the normal executable. All right, so let's make clean. Good. Okay, you can do make partial submit, make full submit. So if I do make partial submit, then I'll have this partial submit.tar.gz file, which is what you dropped straight into the autograder. If you do make full submit, then now you have a full submit.tar.gz. Also, just drop it straight into the autograder. So we're just trying to make that process easy for you. Okay, you can do, make testing, and y'all can go back over all this. But okay, debugging with print statements. One option is we have defined debug in our makefile. So if you want to use these preprocessor directives, they're called in C and C++, then you can put print statements in that will only print in debugging mode. So that's helpful. Yeah, basically you need to make sure that the submission that goes to the autograder is not printing debug statements, because it'll throw the autograder off. because we're doing a diff check on like correct output versus your output. So you need to make sure that these are not running. This is one way to do it. The other way is just to be careful. So either way. Okay, Valgrind is a tool that we use. Detects undefined behavior such as use of uninitialized values. So if you do like int I and then later you use I before assigning to it, it'll catch that. Out of bound reads, oops, sorry. So like if you're going off the end of an array or writing off the end of an array, something like that. Memory leaks, there will only be one place that you'll be doing anything with, maybe like a lab and a project, that you'll be working with dynamic memory in 281, but we're still tracking that. If you use exit status, this will not run the destructors of any of the containers in your program, so that's not a great idea, because you'll be leaking a bunch of memory then, and we track your memory usage with Valgrind on the autograder. And so if you end up leaking a bunch of memory that way, we'll track it and you lose like, I think 10 points. So Valgrind is really great for keeping track of all that. It does memory profiling, but if you want to use it that way. Okay, so let's see. All right. I've got another thing that we can do for this. So we are going to run Valgrind here. We're going to do make. Okay, let's see what's in our thing. Let's get rid of that full submit. All right. So really quickly, let's just look at what is in profiling.cpp. And I will pull up okay. So profiling.cpp is running insertion sort. And we can see here we're reading data. And so while there's user input, we're just pushing that back into an array and then into a vector. And then we're doing insertion sort on that. So it should be sorted at the end, and it's going to tell us what the largest element is. So what we can do is, I'll run it normally and we'll just see how it's supposed to work, I guess. Profiling. Okay, so let's just put in some numbers. Okay, and then I'm gonna hit a letter because that'll cause the CN to fail. The largest element is 3465, that makes sense. Okay, now let's do /profiling, and I'll just hit a letter. We get a segfault. Okay, why did that happen? Let's run Valgrind. Profiling. Okay, let's just hit a letter again. Great, so now we're seeing a bunch of stuff here. So let's start at the top. Here's my input. First thing that happened was invalid read of size 4. It's telling us where that's happening at insertion sort, but we notice there's no line numbers, which is not very convenient because all we know is that it's in this function. And we know that that was called by main, but we already knew that. Okay, so now it's telling us process terminated with default action of signal 11, sigfault. All right, so the rest of this is pretty useless to us at the moment. Okay, so how about now let's do make debug. And let's do so ls, we have this profiling debug. Let's do valgrind /profiling debug. Now, obviously, this is a toy example. If we go to insertion sort, we can probably guess what's going on, right? Like we're indexing into this array, but there's nothing in the array, so nothing is going to happen. But say this is a more complicated problem. We don't know that. We're going to go, hopefully through the debug feature, we'll be able to see what line we're actually failing on. So let's put A in here again. Oh no. I've disconnected from the internet. Okay, so Valgrind /profiling debug. Okay, so we want to use Valgrind now to figure out which line number we're failing on when we run this program with letters as input. Okay, so now, I would never use the bottom to try to guess what's going on. I would always go to the top of where errors are happening, both without Valgrind and with Valgrind, and start reading from there. So there's a bunch of like nonsense here about Valgrind and what you used, and then user input, and then important stuff. So invalid read of size 4, it's telling us what went wrong, and now it's telling us where we went wrong, right? Profiling.cpp colon 36 is what that says if we just expand this a little bit. Okay, so now it's telling us what line number we're actually failing at. So let's go to line 36. Hopefully. Hello? Okay, so we're failing in comp swap. Okay, and why is that? Let's go to 48. We can see that's where it's being called from. This doesn't give us much information. We don't know what's going on here. Okay, here's 48. Comp swap. Oh, we're passing in this null value because we're doing an invalid read here. It's off the end of the array because the array is empty. So, like we thought, doesn't work with just letters. So Valgrind has told us, importantly now, what line we're failing on of these functions. So that's something that is very crucial to you debugging efficiently and effectively in your projects. Okay, great. Let's move on. Okay, so right, here's what we just did. We compiled with -G3, which is what make debug does, and we got the line numbers. All right. So you always want to Valgrind your code before submitting to the autograder, because we use Valgrind on the autograder, and if Valgrind fails on the autograder, then we take points off of your project. So it's always good for you to Valgrind your code. I mean, it's also a reminder that you should be compiling and running your code on Kane before submitting it, always. And once you know what lines are causing problems with Valgrind, you can go farther with IDEs or GDB. But normally, IDEs will tell you this information as well, like line numbers that you're failing on, especially with seg faults and stuff. So another plug for IDEs. Okay, so we just kind of did this part. So yeah, I guess if you aren't clear on any of that, please feel free to email me or go on Piazza or something. I'd be happy to make another video with more information or explain anything. But yeah, that's the Makefile and Valgrind. Okay, Perf is another profiling tool for time issues. So we're going to use Perf right now on the program we just ran. So here we are, we're doing make profile. Okay, now we're going to run this command perf record -- call -- graph equals dwarf dash e cycles u time. Profiling is our executable name. You can see right here. All of this stuff is just options that we're providing to Perf. Well, actually, all of this stuff are options that we're providing to Perf, which is another program that is going. We're telling it what we want when we're profiling this code, which is called profile. How handy. So it is running. Maybe. Is it running? Oh yes, of course it's running. We have to put stuff in. Okay. Largest element, 346, looks right. Okay, all right, so that was, and then you can see all this, there's all this perf stuff. It woke up and recorded data to here. We can ls, and we've got now this gmon.out and perf.data, and we're gonna go look at the perf report. Okay. So here's a bunch of stuff that looks super confusing and annoying. But what I would recommend is let's look at the symbol over on the right side. And what I always recommend with perf is just start at the top and then go down until you find something that you wrote. So main. It's usually, I like to go to main because that's where your program is running. This is like a bunch of STL stuff that we don't care about. Okay, so in main, we see that main is taking up about some large-ish percentage of the runtime. And we can see that read data is taking some time, and operator, when we're reading in, is obviously taking time. So we come here, same sort of information. Obviously, this isn't, a very a great example for this, but on your larger projects where it's not clear where things would be slowing down, this will be very helpful. So let's try running this with. This is how you run your programs. Is with the output redirection, which we'll talk about shortly. Let's run it with that. So we have this test file that's fairly large, I think. Let's look at it. Let's go all the way to the bottom. Okay, so there's 50,000 entries, but there's still no ending to it. So let's just end it. Okay, so now our biggest element was 1,000. Sounds good. But looks like we processed too many events. And we wrote half a gigabyte of data, which is a lot. So obviously this scales pretty quickly. 50,000 is pretty big. Let's look at, okay, we did not need to type A. So let's look at the report. Okay, so this is just too large of a sampling, basically. When I ran this earlier, it was fine. Okay, let's just keep going for now. But this is how it works, and you can do it on your own, and this is what you would do. Just provide your project programs here. Okay. We did a demo, and you'll do a bit of this for this week's lab assignment. Okay, input and output in C++. C in, C out, and C error, read and write to standard in, standard out, and standard error, respectively. IF stream, OF stream, and F stream were objects that I believe you used in 280. I mean, it's probably a different class than when I took it, but that's what we were using when I took it. So these are all file streams. These are input streams. These are what we'll be using in this class. Like the example I just did, you can see we can do /profiling. And we're going to, we're reading in, what is it, test one. This is redirecting C in for us. So where there's that user input, we're using this file. Okay, now, this is what I just said. This is the important part here. Directions for redirecting input on Xcode and Visual Studio can be found on Canvas, but also, this is usually a big problem for people just getting it to work the first time. So don't hesitate to ask. Because it's kind of, you really have to get down into the depths of Xcode and Visual Studio to do this. But you want to be able to run your project with the correct input files on your IDE or in whatever environment. So that is an important step to take before the project. Okay, you can specify a file you want to associate. So here we're writing to this file called output. In this example, we were writing from a file to the program, reading from. Okay, so this is what's going on in that program, right? We're doing profiling. Nope, not the binary. Profiling. Okay. So here, right, we're reading in from the command line. And while we're reading this, we're doing something. We're just appending to this vector, which we pass by reference. So then after this, the vector will be full. You can also do while getLine is successful. So this is a nice structure because the while loop will just continue until there's no more input. Using these other forms like .eof, .good, .bad, .fail are prone to failing on edge cases. So we definitely recommend trying to do it this way. Okay, so we're trying to read. There are different ways to read off of the command line or from user input or whatever. This code is not going to preserve white space. So we're just grabbing characters. We're reading into characters, individual characters from the input. And so we just read all of these. It's going to ignore this white space. It's going to ignore the new line. It's going to ignore that white space. And it's just going to print out the characters. So just to really explicitly go through this, we ignore the leading white space. Then we consume a word. Here we've got a string now, right? Which is why we get a whole word instead of just a character. And then it goes up until the next white space. Hello? Okay. Ignores this white space. We take the next word. It's going to ignore the next white space, which is the paragraph, or the paragraph symbol, but the new line, and whatever leading space there is here. And then consumes the next word and so on. Okay. So now that we've read the entire file, there's no new line here. This is false, so this loop terminates and your program continues. This does preserve white space. We're getting an entire line, and then getLine will stop reading into the string, which we have here, which we're passing in here, when it finds a new line. Or you can provide any character. So you could provide like the pipe or whatever. You could, I mean, you could put like X in there, A, but it just all depends on how your data is. Okay. What gets printed? This, because we're preserving these pieces of white space. We're preserving this new line. Consumes all characters, even white space, until the given one, which is default new line. And which, if you had another comma here, you would pass in as a character. And then it removes and discards the characters. So it reads all of this. It's going to stop at the new line, and then removes, discards that, and reads the next. And then that will fail because there's nothing left in the file. Okay. So if you're using both of these, there can be some trickiness there. You just have to watch out for you have to be really careful for what you're actually reading in with cin or getLine. So here's an example you can walk through. Okay, getOffLong is, so we're going to transition from talking about profiling tools into, I guess this isn't really profiling tools, this is just more like general help. But now we're going to transition to something very specific for the projects. getOffLong processes command line arguments. So when we have this command here, there's all these arguments, and if a user is providing that to one of our programs, then we have to be able to process these in a smart way. So that's what getOffLong does. So it's just going to do that for us basically. We don't, there's this whole paradigm of like you want to be able to use the long form, which is dash dash first, or the short form dash F, and you want to be able to use them both, and you want to be able to use them in any order, and all of this. So it's important that we have a tool that does this for us, because it would just be horrendous to write ourselves. And we want the program to work similarly in all of these different ways. So it's nice to have getOffLong. Here's an example of the code. We have to include the getOff code. We have our main here, and then this is all setup. We're doing a whole bunch of setup. We do a bunch of setup, and then there's this big like switch break statement that is just iterating over the options, and then we have cases for what we should do on each of those options. So importantly, we need to set up this array of objects, of option objects. And so you can see there's a constructor here, and then this is also a constructor, right? We're calling it a constructor of this option type. You pass it the long form. You say there's no argument after. If there's, like here, if we were, let's see, this is not a good example. Let's say profiling took a, this action argument, and we did dash dash action, and then it took like an integer or whatever. This would be the argument here. So either in this class, there's either no argument or there's a required argument. There's no optional arguments. There is in getOffLong, but not in this class. So either we expect there to be nothing following this option, or for there to be something. So equivalently, we could do dash A5, something like that. Okay. So we do the long form. We say if there's an argument to follow this or not. This we just always leave as null pointer for now. We don't deal with it. Just don't worry about it. Leave it as null pointer. And then the short form. So this should be a character. This should be a string. Usually it's like the first letter of this. Number, and so number takes a required argument and null pointer. And then you have to have this null object. you can think of this like the end of a C string, basically. Like the end of a C string has the sentinel character, so we know that the array is done. This is all written in, get out long is all written in C, so they require this null object at the end of the options array. So we set up all our options here. Then we have this while statement. The only thing that you should be changing from implementation to implementation, like different projects and stuff, is this string right here. From this line, all you need to change is this string, and you'll just enumerate. You have A, you have N, maybe there's like a P, maybe there's an X, something here. So all of the short forms would be in this string, and any option, so any of these objects that has required argument needs to be followed with a colon. So to be clear, I'm just going to write here. Let's say action also had a required argument, then that string would need to be like this, because action has a required argument and also number has a required argument. It could be the case that it was like this, and then action would have a required argument, but number would not. If you have, let's say you have a bunch of different things and they all have required arguments, except for A, I guess. Oop. Oh no. Okay. It could look like this. But yeah. So then in here, you're switching on the characters in this string. So case A corresponds to action. Case N corresponds to N, which is number. And on these different cases, you want to do stuff like you want to set a parameter in your program, or you want to, the command line is telling you to do something, or it's an option that your program provides. So you need to take action in this switch break statement according to what the user has set. Yeah, and then opt arg here is very important. That's when it says required argument, that's the argument that was provided by the user. So this global variable called opt_arg, and it's a character pointer. So it's an array of characters, not a string. So you have to do some, you're gonna have to process that information somehow. A to I works if it's an int, but you can, there's lots of different processing for if it's a string, or if it's a float, or if it's a Boolean, or etc. Okay, great. That's get opt long. Please, be very forward if you don't understand what we just went over, or if there's something that doesn't make sense, or a part of this that you're not quite getting. If you're getting errors on your first project about get opt long, please, email me or post on Piazza, or come to office hours or something, because it's a very quick fix for us. It's very quick for us to notice what the problem is, and it'll save you a lot of time of wondering oh, how should I format my string? It's very, very simple for us to just look at that and let you know. Okay, moving on. Abstract data types. Collections of operations and their behaviors on whatever data you're interested in. That's an abstract data type. It's an interface to the data, and the implementation is usually what we call a data structure. We want you to understand when to use ADTs, why you want to use ADTs, and how different operations that you're doing on those data structure, or on the ADTs data types, affects time and memory. Those are all very important.
Okay, so we're going to talk a bit about stacks and queues, and we'll talk a bit about the ADTs for these because we're not yet talking about the implementation. Now, this is where I wish I had something to draw with, but a stack is, you think of it like a stack, essentially. It's a stack of plates. And so when you are dealing with the stack, you can't deal with, the middle plate. You can't deal with the plate on the bottom. All you can deal with is the plate on top. You can put another plate on top, or you can take a plate off the top. That's exactly how a stack works. So let's look at. I'll just write out some stuff. So if our stack is, we'll just do this in comments. So imagine we have a stack. Then if we add to this stack s.push 5, then let's do this. So whatever that whatever this stack data structure might be, we're going to, so let's do s equals, it's just empty. Now, after putting 5 in, it's going to be 5. And let's put another element in there, 8. So now s is 5 and 8. So if I do s dot top, what I'll get is 8. Stacks always just return the last thing that you put in. So we refer to them as a last in, first out data structure, as opposed to queues, which are first in, first out. A queue you can think of as a line. I think we've all dealt with queues in real life. The queue abstract data type in computer science is exactly the same. You can put elements at the back of a queue, and you can get elements from the front of a queue. Generally, you can't, grab anything out of the middle of the queue, and stuff like this. So, it's I think the name sort of explains what the data structure is, which is great because a lot of names in computer science don't, I think. But yeah, so let's just look at a quick example. We're going to have a queue. And so right now, queue is empty. Now let's do queue.push. We'll push 5 again. So now our queue looks like this, or something similar. And bear in mind, the comments are like going into maybe a little bit about the underlying implementation, but you don't have to worry about it. I'm just trying to show what the data structure would look like. So let's put 8 in. Now Q is going to be 5 and 8 still, but Q.front we'll use instead of top because I tend to think of queues like horizontally while I think of stacks vertically. And so that makes sense because, well, to me at least, because you're like grabbing things off the stack. The queue is like a line, so you're pulling things out of the line. But however it makes sense to you. So the front of the queue is 5. And that's what we refer to as a first in, first out data structure. And that is what defines a queue. So we have push to put anything into our data structure. We have pop, which removes the element that would be returned by top or front. And then we have size, which is self-explanatory and empty. Okay, so we can't get into the middle of these data structures. What are common things that we might use stacks and queues for? Whenever I think of stacks, my first thought is like the browser back button is a stack. You want a last in, first out data structure there because you want to go to the most recent page you're at. You don't want to go to the first page you went to in this browsing session. A queue, I tend to think of like, say you're running a ticket selling business online, and you're just releasing, tickets for a new concert or whatever, and people are going on your website to buy the tickets. Maybe you have a finite number of servers and positions that can actually serve the like ticket sales at a certain time. So maybe those are all full. Now, new users coming to the website, you want to put them in a queue, because whoever gets to the website first, you want them to have access to the tickets before people who get to the website later on. Other examples of places you could use queues would be like operating systems tend to use queues a lot for scheduling tasks on the kernel and things like that. So we'll talk about the implementation of stacks and queues a bit later in the semester, and different like problems that you can solve with them. Okay, so a deck essentially implements both a queue and a stack simultaneously. You can access push and pop at the front as well as at the back. So if you want it to be a stack, you just choose pop front and push front, and if you want it to be or push back and pop back. If you want it to be a queue, you would use push front and pop back, or push back and pop front. So what this means is for project 1, you'll be able to switch the algorithm by just having like 1 or 2 lines difference if you use a deck instead of like a stack and a queue. So that's nice. And then, of course, it does front, back, size, and empty, just what you think they would do. Decks also support random access in the middle, which is not as efficient as a vector for reasons that deal with the implementation of how these work. But you don't have to worry about that at the moment. And you shouldn't really be using the random access anyways. So yeah, you'll just be using the push front, push back, pop back. All right, cool. We can talk a little bit about vectors and how to use vectors and what vectors mean. So a vector is similar to a deck, but they don't have push front and pop front, and in exchange they have better performance. So if I have a vector of integers v, and I set this up like this, then what we have is we have v. V is an array, but we also have the underlying components of v. Maybe we have like v dot pointer is a pointer to a C array, array of ints, which is 1, 2, 3, 4. We have v dot size, which at the moment equals 4, and we also have v dot capacity, which also equals 4. And these are equal because we used this constructor, which just creates the array with exactly those elements on the heap when you instantiate it. Okay. So they're good for implementing a stack because you already have push back and pop back, and that's what a stack needs. But really what we use them for most of the time is fast random access. We can get into any position in this array very quickly because it is just a C array. It's contiguous memory. We know exactly where the element is on the heap. So they're very fast for that, which is good. Okay. Vectors should be used for data that require random access. And we're going to talk a bit about how to optimize your computer's memory for a vector. If you know what the maximum size is of that vector before you are adding elements, you can use these tools resize and reserve to help you optimize the amount of memory that your computer is using for that array. Basically, the issue is that you'll find that if you have a vector and you don't use resize or reserve, it's possible for that vector to be double the size that it needs to be on the heap, which is it's a waste of memory. So we'll talk a little bit about that. Okay, so let's dive a bit deeper into that problem. So let's say I did v dot push back 11. Now our vector is 1, 2, 3, 4, 11, but I'm going to use array for the array on the heap. The array is 1, 2, 3, 4, 11, 0, 0, 0, 0. Is that right? Like this. So what happens is we have a size 4 array on the heap initially, right here. Then we add an element to that, which means we need to allocate an entirely new array on the heap. We copy in the first 4 elements. We put in the element that we were asked to push back, and then the rest of the array is default initialized. So the vector still looks, the way you would expect it to, but under the hood we've done this like, these n copies basically, where n is the size of the array before this pushback. In this example, maybe these 3 extra zeros aren't that big of an issue, but if we had 1 million elements that were valid, maybe we had 2 million elements in the array, and 1 million of them are just being unused, so that's not great. All right, so let's look at what the other parts of the array are. So at this point, v.size is 5, and v.capacity is 8. And that's because size is the size of the valid elements in the array, while capacity is the size of the underlying array on the heap. So yeah, it's the difference between these two. Let's see. I want to say that v, I'm saying that v exists here, but v is not like, v is our vector, but v, there's no like memory that holds just this. V is just everything in this array that is valid. So it's these 5 elements, indices 0, 1, 2, 3, and 4, all before the size of the array, right? So anything over here is not part of v, but it is in our array, and it contributes to the capacity, but not the size. Okay, so let's talk a bit about resize and reserve. So I'm going to create like these little scopes here that are not valid code, but will serve a point for us. I guess they're valid code. So let's see. Let's reserve. Let's start with resize. Let's resize our array to size 10. I'm actually going to knock this back. Okay, so now that we've resized, v looks like 1, 2, 3, 4, 5, 11, 0, 0, 0, 0, 0. Okay, our array looks like 1, 2, 3, 4, 5, 11, 0, 0, 0, 0, 0. Okay, so all of a sudden the vector and the array are the same. v.size therefore should be 10, and v.capacity will also be 10. Okay, now let's look at reserve. All right, v.reserve. So now we're pretending like we are back at this array, not having done this. We'll reserve, and then v equals 1, 2, 1, 2, 3, 4, 11. A is 1, 2, 3, 4, 11, and then there's these 5 spaces here which are junk, which I'm calling J. But it could be anything, right? They could be 0, they could be 1,000,000, they could, it's just whatever happened to be in memory there. v.size is 5. v.capacity is 10. So here we've changed the size of this underlying array, and we haven't changed the size of our vector, which means that the capacity is 10, the size is 5. So when you're working with reserve, what you're doing is trying to you're allocating a space in your array for you to use in the future, and when you're working with resize, you are actually changing the array, and then you can work with that data from there. So resize changes size and capacity. Reserve just changes capacity. Okay. Vectors have a data pointer, a size, and a capacity. That's what these 3 things are. Size is how many valid elements are contained, and capacity is just how big the underlying vector is. Okay, so you can go back and look at all that if you would like. Let's see. I do want to talk about how you add elements to these. So let's stay in the resize scope and do a pushback. Let's push 5 back because I keep messing that up. So now v would equal 1, 2, 3, 4, 11, 0, 0, 0, 0, 0, 5. Right? Because we added something to the end of our vector, and our vector already had all these elements in it. Right? So now we have like a bunch of junk in the middle of it, and then another valid element, which is bad. This is not good. So in that case, our array would also have doubled in size. So I'll write it out, but it's not going to be nice. 0, 0, 0, 0, 5, and then there's going to be 9 entries of junk. 6, 7, 8, 9. Because 5 was the first of sorry, I was pointing at it. 5 was the first of the 10 new positions, because we're doubling the size of our previous vector. And then there's 9 positions of junk after that. So this is not good. We didn't use like these values, which were meant to, they don't mean anything to us. And instead we added all this stuff at the end, and there's still all these, right? So it's not good. I've made that mistake on projects before in 281. It's not fun. So here what we'd want to do is something like this, and then I guess I haven't really been doing code this whole time. And then we'd get what we wanted. Like this. And A would be the same. Okay, so let's just do the same thing for reserve now. So v dot push back does what we want. So let's do that. Now v is 1, 2, 3, 4, 11, 5. Our array is 1, 2, 3, 4, 11, 5. Junk, 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 junk. So that looks good. V dot size is now 6, v dot capacity is still 10. So I guess we should do that here as well. Here, v dot size is 11, and v dot capacity is 20. So that's where it goes wrong. And in this example, v dot size is 10, and v dot capacity is also 10. So that's good. Okay, pushback. Now let's do v at 5 equals 5. This is just a cycle because we can't index into positions in our array that don't have valid elements. So that just won't work. Okay, so that is resize and reserve. Hopefully you learned from that. Just to cement things, I'll use an analogy about a bucket very quickly, but it is the same as this. So let's pretend our bucket is our vector, and we want to fill it with water. So when we resize the bucket, or in code it's our vector, we're changing the bucket. We pour in our old water, and we're also filling up the bucket at the same time with more water. When we reserve, we change the bucket. We put in all our old water, but we don't add any new water. So the volume of the water inside doesn't change. The number of valid elements inside the vector doesn't change, but the size of our container does, and the available volume for new elements does change. Okay, so here we create an empty vector. We reserve 10 positions. We index into the first position, or the 0th position, and then we also try to call empty. So what happens here, this is going to fail because there's nothing there, right? I mean, there's an array there, but there's no valid elements. All we've done is reserve. So this will segfault or produce undefined behavior, something like this. Empty will be true because there's nothing in it. All we've done is reserve. So that's how that works. If empty is true, you can't index it, right? Okay, so here's a little more information for you to look back on when you want to review for the exam or something, but I will skip for now. We're going to talk just shortly about multidimensional vectors for project 1. Here's one way you could do it. Vector events, and then you're just pushing back like these temporary vectors that you've added elements to onto your vector until you have 10 of them. So it seems like a reasonable enough way to do things, but it's not efficient. There's better ways to do this because here, right, we're growing our arrays. We're not sure what the exact size, or well, we know what the size is, but not the capacity at the end. Here's another way to do it. We could do vector of ints, reserve 10 places, and then push back these temporarily constructed vectors into that. These to be exactly the size they want. We know the size here. That's fine. So this will produce a data structure that is exactly the size we need it to be. So that's great. It's still, 1, 2, 3, 4, 5 lines of code, which is fine, but we can do it in 1. So why not? So vector of ints, myvec, you just construct it with the number of elements. You construct it with what the element should be initialized to, which is another vector of integers. And then in there, we're saying those should be of size 10, and they should all be zeros. So that will work for 3D dimension, or for 3D vectors, 3 dimensions, or anything more. You can just keep wrapping it in more vectors of vectors of vectors of vectors. And this is what you want to do in project 1 when you're initializing your map. Okay, so we just want to talk a little bit about some examples of where certain data structures might be useful, or ADTs. So let's think about, we want to keep a list of the names of people in the order that they entered a classroom, and we want to be able to find the name of the nth person who entered. So we want an ordered list. We want a data structure that preserves order as you add elements to it. So one data structure that wouldn't do this would be like the STL map, for reasons we'll talk about later in the semester. But basically the elements move as you add more elements, so that's not good. What I think of is like a vector, right? You can just put elements in, you can take elements out. We don't need to, but we put elements in, and they stay in the order that they need to be. And then we can use random access, which is be able to find the name of the nth person who entered. Someone gives us the number n, we just need to find the name, so this is probably like a vector of strings, and we want to be able to index into it. Okay. We want to simulate traveling from one road intersection to another, and then backtrack in the exact opposite order once some condition is met. So, earlier we talked about like stacks being used for the browser back button. In my mind, this is basically the same thing, right? We're traveling from the start of our browsing session to another point in our browsing session, and then we backtrack in the exact opposite order. I want to go to the most recent page I was at. So a stack I think is pretty reasonable for this. All right, we want to serve requests received by a modem in the same order that they were received in, so that to me says first in, first out, which means a queue. And we want to retrieve a list of students who picked each number between 0 and 10 when asked for a random number between 0 and 10. So 0 and 10, I would say we could just have like a vector, and elements in the be 10 large, and then elements of that vector would be vectors of strings, which would be these lists of students or objects. And then you could index into one of those 10 positions, and you'd have a list of students that had picked that number. Okay, map also, but that'll be later in the semester. All right, here's the handwritten problem. I think you have seen this somewhere else, but yep. So turn this in on Gradescope, and that is all. Thanks for watching. I will see you all around Piazza. Bye.